All right, for Gaussian elimination, we're going to be doing the same thing we did earlier this week, except we don't have the steps given to us. We're going to have to come up with those steps or those commands on our own. So it says that our goal is to rewrite an augmented matrix in reduced row echelon form by using elementary row operations. So first off, this reduced row echelon form, that's what your calculator gives you when you run that RREF command. So remember, we want that to look like the identity matrix. Augmented or combined with your solutions. So this is going to be your solution for your X, your Y, and your Z. So that's our goal, to get that diagonal of ones surrounded by zeros. Okay? In order to do that, we can perform what we refer to as elementary row operations, or those things that we were doing the other day where it was like 2 times row 1 plus row 2, and we write it down in a specific row. So valid row operations are either multiplying an entire row by a non-zero number. So like if I had 2, 0, 0 in my top row and I needed to get the 2 to become a 1, we could multiply it by a 1/2. Okay? You can add a row or a multiple of a row to another row. So that would be like row 1 plus row 3, or -2 times row 1 plus row 2. We can do that at the same time as an elementary row operation. And then finally, we can swap 2 rows. So maybe we have our 0, 1, 0 in the top row and we want to move it to the middle. We can just say swap row 1 and row 2. So the easiest way to learn this is just to hop right in. So first thing we need to do is set up an augmented matrix for that system of equations. Is it in standard form? Yes. So we can just directly transfer all of our coefficients into a matrix. So I gave you a hint. I said, as you begin, try to get zeros in the bottom left corner. Okay? That means we're going to focus on these 3 values right here first. If we can get rid of those 3 values first, it's going to make the rest of our matrix happen a lot quicker, because we're not going to be undoing things that we've already done. So let's just look at this one right here. How could I turn this 1 in row 2 into a 0? What would I need to add it with or multiply by? Okay, which row? You want to multiply this row by a -1. Okay, so -1 times row 2. What do you want to add it with? Row 3, okay. Could we have also chosen to add it with row 1? Yes. Okay, so the path you take on a problem might be different than someone else's. And we said we want to change row 2, right? Because we want to make this into a 0. So we're going to draw an arrow to say that we're going to write our answer in row 2. So in order to help keep us on track to where we're not replacing wrong rows, what should we do first? Yeah, we're going to write down row 1 and row 3 first into a new matrix so that we don't accidentally change numbers that we don't need to change. So we're going to replace row 2 right here. So to get my new values, I'm going to go ahead and I'm going to just do this multiplication in the existing matrix. So this is going to be negative, negative, negative. And then you said we're going to add these with row 3. So -1 plus 1 gives me 0. -2 plus 3 gives me a 1. -3 plus 4 gives me a 1, and then 0 plus negative 2 is negative 2. Which one do you want to do next? The 1 or the 3 down here? It doesn't matter. The 1, okay. So here we've only got one option really, because I can't multiply 0 by anything to cancel it out. But what can we do? How can I change this to a 0? It's going to be similar to what we did up here.
Same thing.
Okay. She wants to do negative 1 times row 3. Add it to row 1. Add that negative 1 to a positive 1. And we're going to change row 3. We're going to write it in row 3. So I'm going to go ahead and create a new matrix. Copy over row 1 and row 2. And then we're going to change row 3. So we're going to multiply this bottom row by negative, so changes these 3 values to negative. That one becomes a positive. And then we're going to add them up here to row 1. So 1 plus negative 1 is 0. 1 plus negative 3 is negative 2. 1 plus negative 4 is negative 3. 3 plus 2 is 5. So we've got one more 0 we need to get to finish this bottom corner, and that's this negative 2. I'm going to give you a hint about this negative 2 though. Okay? We need a positive 2 to cancel with it. So I could either multiply this one or this one by a positive 2. Why do you think we should use the second row? Because it has a 0. If I used this one, multiplied it by a 2, and added it to my third row, what's going to happen to this 0 we already got? Well, it's going to become a 2, right? Because we'll have multiplied this. So we don't want to add something that's going to get rid of this 0 we already got. So we're going to strategically use the middle row so that 0 plus 0 stays 0. So I need to do 2 times my middle row, 2 times row 2. We're going to add it to row 3. And we're going to write our answer in row 3 because we want that negative 2 to become a 0. So we're changing row 3. Copy over the top 2 rows. I'm going to go ahead and multiply over here in this matrix. So we have that. And then when I add them together, 0 plus 0 is 0. 2 plus negative 2 is 0. 2 plus negative 3 is negative 1. And negative 4 plus 5 is 1. So did we get zeros in the bottom left quarter of our identity matrix? Yes. Okay. Next part of the hint says work on getting the remaining zeros. So that's going to be this top right corner. We're going to work on getting those to be zeros. I see 2 of them that we could get really easily. Which 2 can we get really easily? What happens if I add row 2 and row 3? That one becomes a 0, right? What happens if I add row 1 and row 3? It cancels out. So if you were working on your own, I would be okay with you doing those in the same step and just writing two different row operations. You could add like row 1 plus row 3 into row 1, row 2 plus row 3 into row 2. But I'm going to do it as two separate. So I'm going to add row 2 and row 3 first. I'm going to do it as two separate so that you can follow in your notes and know exactly what's going on. So we're going to get that 0 in row 2 first. We're not multiplying anything, we're just straight adding row 2 and 3. So 0, 1, 0, negative 1. We've got a value for y. Y equals negative 1. And then we said we're going to do the same thing with row 1 and row 3. And we're going to write our answer in row 1. So we have 1 plus 0 is 1, 1 plus 0 is 1, 1 plus negative 1 is 0, and 3 plus 1 is 4. So I've got in that matrix 2 of the 3 zeros we need up here in the corner. So I just need to get rid of this last value. How can I get rid of that 1? You can. You can multiply row 2 by negative 1 and add them together, or you can multiply row 1 by negative 1 and add them together. It doesn't matter. Okay, so he says multiply row 2 by negative 1. We're going to add it to that top row, and we need to change the top row. We need to change row 1. We multiply these by the negative, so they're opposites. So I get 1, 0, 0, 5. I've only got one last value that we need to change. Everything's the identity matrix except for this guy right here. How do we do it? How do you just change the sign on something? What do you multiply it by? You can multiply it by a negative 1. Negative 1 is going to change the sign. So we just do negative 1 times row 3, and that's our new row 3. So that's just going to change these two signs. We're not adding it to anything, so we have 0, 0, 1. Negative 1. Is this the identity matrix? Yes. So this is our identity, and this right here is our solution. So since we have the identity, this represents our x, our y, and our z, and we can write it as an ordered triple.